Hello, everyone. This is our outcome report for developing an experiment with virtual connectivity. And we are supported by the Summer Sandbox grant from WPI. The project team is Jordan Jonas, Kerry Thornton, and myself, Ahmet Can Sabuncu. Next slide, please. The goal of our project is to develop a physical experimentation setup to teach evaporative cooling. And the distinctive features that we have is are it is a low-cost setup, and as well as our technology allows students remotely control the setup and acquire data.
So in the first semester of 2020, Professor and I started creating the evaporative cooling lab setup. It sent sensor data from an Arduino to Google Sheets and live streamed video to an IP-dependent URL. In the spring of 2021, we made some modifications so that the sensor data, instead of being sent to Google Sheets, was sent to ThingsBoard, which was more versatile. But we couldn't yet control devices via ThingsBoard or go beyond just passively receiving data. And we also couldn't live stream to ThingsBoard. So this summer, we researched how to live stream to ThingsBoard. We realized that the URL needed to be not IP dependent, it had to be just a permanent address. So we used an online service that's free, and it sends the contents of port 80 on the Raspberry Pi to a permanent URL. And then we can take that URL and embed it into the ThingsBoard dashboard so we can live stream to it. We also learned how to control GPIO pins on the Raspberry Pi via ThingsBoard. So we were able to turn 5 LEDs on and off using a control widget on the ThingsBoard dashboard. And currently we're working on limiting the student dashboard control based on time so that we can ensure only one student can control a device, which here is our fan, at a time so that multiple students aren't sending different commands simultaneously.
So some of the images that you're seeing here are our original setup for our prototype design, as we talked about earlier in the year. Our setup has been updated a little bit since then. However, it's still under construction as we're getting it ready for our test in B term. As you can see, there is a kind of shower head for the evaporative cooler, the fan that will be turning on and off, the DHT sensors, and the camera setup. There we go. So to talk about what I completed over the summer, I was able to research and complete a live feed of DHT sensors on our new ThingsBoard server. I worked with the ARC networking team to resolve the WPI network errors that we were having when connecting our Arduinos and ensured long-term connectivity of the sensors to the ThingsBoard network so that it would lower the amount of maintenance needed. I also researched and completed wireless GPIO control through ThingsBoard, again on the WPI network. The Raspberry Pi GPIO control proved to be a little too tangled in the WPI network encryption to pursue, so we changed to the Arduino MKR 1010 Wi-Fi board, which proved to be easier but far less dynamic. To continue, I was also able to set up and configure a video live stream using the Raspberry Pi camera, as mentioned before, and worked through the WPI firewall encryption to produce a steady live stream with minimal latency. In addition to that, we were also able to refine our physical setup for a class test in B term, as I mentioned before, with ME 3092 students. And combining with Kerry's research to limit the students on the dashboard, this newer setup will require less maintenance and will feature long-term connectivity. So as to mention our three major conclusions, using what we've learned this summer from the experiment, the team feels confident we have created a powerful template for remote data collection and experimentation. Our data collection can now be done from anywhere a student can access the internet and ThingsBoard, allowing in global participation and experimentation. And to follow the trend of the increase of remote and online learning, this experiment has the potential to help bolster the effectiveness of remote learning, allowing students to get a nearly hands-on experience as they would in a normal lab. Thank you so much for tuning in.